Welcome again, children. It is Halloween night, and it is time for yet another scary video. This one is the scariest of all. It's called Completing the Square. Now, when we last met, we discussed lots and lots of complex factoring. And one of the things we looked at was a perfect square trinomial, where you have this little thing and then it's squared. So if we were to FOIL this back out, and I will do that with you, x plus 3 times x plus 3, then you get x times x is x squared. And that's my dryer. And x times 3 is plus 3x. And another 3 times x is plus another 3x. And then 3 times 3 is 9. So that perfect square trinomial is x squared plus 6x plus 9. And when you do this, and when you do any of your perfect square trinomials, you will notice that the last term is always half of the middle term squared. So if I took 6 and divided it by 2, I'd get 3, and if I squared it, I'd get 9. And you can practice this with several others, but that'll always be true. So we always end up with x squared plus bx plus, and then half of b squared for our perfect square trinomials. Now, the reason that we care about that is because sometimes we want to make an expression into a pretty perfect square. So in order to make an expression into a perfect square, all you have to do is get x squared plus bx by itself, move everything else over to the other side of the equation, and then you can add half of b all squared to both sides of the equation, and you'll have a pretty perfect square. So write that down. For our first example, we're going to solve x squared minus 4x minus 5 equals 0. And this is one we could solve by factoring. In fact, let's do that real quick. We could factor that into x minus 5 and x plus 1. And so that means x would be 5 and negative 1. But another method for solving is completing the square. It's actually useful for more difficult ones that don't factor, but I'm going to show you how to do it with one that does so that the answer comes out nice and pretty. Alright, so to complete the square, the first thing you need to do is move that negative 5 right there out of the way, because we want to isolate x squared plus bx. So we want x squared minus 4x, and then leave some space and write equals 5. That space is important. You want to leave a space right here, because we're going to complete the square. We're going to add something there, and if we add something to the left side of an equation, we've got to add it to the right side. We're going to add something to both sides of our equation to make this side into a pretty perfect square. And so you say, well, you're going to add half of b squared. b, in this case, is negative 4, and half of b is negative 2. And if I square negative 2, I get positive 4. So the special number that I'm adding to both sides is 4. So now when I factor the left, I get x minus 2 all squared. It's a pretty perfect square. We have a perfect square trinomial. And it's still equal because we added 4 to both sides, so it's still okay. But now we just say equals 9. And then, because we're trying to solve for x, we go back to what we did before when we were doing our radicals and square roots. And we say, alright, so now if we want to get rid of that squared, we're going to take the square root of both sides. So x minus 2 equals plus or minus, do not forget it, square root of 9. X minus 2 equals positive and negative 3. So that means that x equals 3 plus 2, and x equals negative 3 plus 2. So we have two answers. X equals 3 plus 2 is 5, and negative 3 plus 2 is negative 1. And we already knew that. That's what we got when we factored it. But that's how it works with completing the square. You can solve that way too. And I know you're thinking right now, you're saying, but that's harder than factoring. And yes, it is. But when we get to ugly ones like this, that don't factor, we can still solve. They're still answers. They're just not nice, beautiful whole number answers. So we're going to look at this, and if we were to try to factor it, we would say negative 3 times 4, AC is negative 12. And what factors of negative 12 add to give us 3? And I'll save you the time. There are none. So what we're going to do is isolate the x squared plus bx. Remember, x squared, no a, plus bx. So the first thing I need to do is move this 4 out of the way. Alright, so I now have negative 3x squared plus 3x equals negative 4. And now I also have to get this negative 3 out of the way. And the way to do that is to divide all the terms by negative 3. So when I do that, I get x squared, and then 3x divided by negative 3 would be minus 1x, and then I'm going to leave space because I know I'm going to need to complete the square, and then equals negative 4 divided by negative 3 would be positive 4/3. Alright, so I need that space there, and if I have one on the left, I have to have one on the right. So x squared minus 1x plus something equals 4/3 plus something. And that something is always take b, half of b, and square it. If I square 1/2, I get positive 1/4. So that's what I'm going to add here and here. And then when I factor this, I get x minus 1/2 because it's always going to be the b over 2 right there. B over 2, see, was that. And then squared equals, and then we can add 4/3 and 1/4. Our common denominator is going to be 12, so we get 19/12. We're not done. We're trying to solve for x. We know this isn't going to be pretty. We're going to have to deal with fractions, but that's okay. We're big boys and girls in pre-AP, and we can handle it. Okay, scooting that up a little bit. We are going to now undo our square. So we're going to say x minus 1/2 equals plus or minus, don't forget, square root of 19 over 12. Now this comes where our radical simplifying comes into play. So that is going to be the square root of 19 on top, which does not simplify, and then 2 root 3 on the bottom, which we have to fix by multiplying the top and the bottom by the square root of 3. And 19 times 3 is 57. So I have x minus 1/2 equals plus or minus, and then 19 times 3 is square root of 57. And then 2 root 3 times root 3 would be 2 times 3, which is 6. And we're almost done. We still need to get x by itself. So we need to add 1/2 to both sides. X equals, and then I'm going to move it over there, positive 1/2 plus or minus the square root of 57, which doesn't break down. If it did, you would, but this one doesn't, all over 6. And that was a lot of work, but now we have the answer without a calculator, and it didn't even factor pretty. That's why we use completing the square. Now another thing you can use completing the square for is converting a standard form equation of a quadratic into vertex form. And the way you would do that is you once again need to isolate x squared plus bx. So here we're going to need to move this negative 8 over. I'm going to put it over there. So I now have 8 plus y equals x squared plus 2x. Then we complete the square. So we half the 2, which is 1, and square it. Half of 2 is 1, squared is 1. So we're going to add 1 to both sides of the equation. And we now have y plus 9 over here. And then this factors to x plus 1 all squared. And then to put it back as an equation, we just move the 9 back over. So we've got y equals x plus 1 all squared minus 9. And that's vertex form, with a vertex of negative 1 and negative 9 as your vertex. It's a real quick way to convert from standard form to vertex form. And I'm going to do one more example of this, a more difficult one, and then we'll be done with this video. Okay, so we want to convert y equals negative 3x squared plus 12x minus 4 from standard form into vertex form. We have to isolate x squared plus bx. So in this case now we need to move the negative 4 over to the other side. So I'm going to add it to y. I'm going to have 4 plus y equals negative 3x squared plus 12x. We also have to get rid of this negative 3 right here. So we're going to divide every single term, and you cannot skip any of them, by negative 3. All of them. That gives us negative 4/3 minus y/3 equals x squared minus 4x. And we did that so that we can make a pretty perfect square. Halving 4 and squaring it, half of 4 is 2, squared is 4. We're going to add 4. And you have to remember to do it to both sides. So I'm just going to put it right there. So when we have 4 minus 4/3 minus y/3, 4 minus 4/3, that's the same thing as saying 12/3 minus 4/3, so that's 8/3 minus y/3 equals, and that factors to x minus 2 all squared. Now we want this in vertex form, so now we need to get y back by itself. And the best thing to do now is to take this 3 that's on the bottom of both of these and just multiply everything by 3. So that we have 8 minus y equals 3 times x minus 2 all squared. And then we'll subtract 8 from both sides. So we'll go minus 8, and we get negative y equals 3 times x minus 2 all squared minus 8. But we want y to be positive, so I'm going to divide everything by a negative 1 and get y equals negative 3 x minus 2 all squared plus 8. And that is vertex form with a vertex of 2, 8. Okay, kids, here's your joke. Here's the creepy scene. Take a look at this graveyard full of pumpkins. One of these pumpkins has a math symbol on it. You have to look closely. So I'm going to give you guys a couple minutes and then I'll reveal the answer. I'll reveal where it is. So look closely. Look, look, look. Boom! Gotcha. Did I scare you?